It's a pleasure to meet you again on this platform. This is our second contact in this course. That is Intro to Oil and Gas Exploration. And last week, we spent an hour and 20 minutes explaining this course. So today, I'm not going to, because of the duration, I'm not going to do any summary of the last class. So what we just do is to just go straight to the topic for today. I have many subtopics trying to make you to understand what exploration is. As at that last time, I was trying to let you know what the origin of crude oil is and natural gas, because you cannot be exploring for what you don't know how it originated. And I believe by now, every student understands the origin of crude oil and natural gas. And every student understands the basic things, features that geologists and geophysicists and petroleum engineers are looking for when they are exploring for oil and gas. Now, I told you that I made a reference to you that last week, but today we're going to be talking about sedimentology as our first subtopic. We're going to be talking about sedimentology. Yes, so when we are talking about sedimentology, it may look very big to you, but in geology, this is one of the basic aspects of geology. That is sedimentology. Is it clear to you? What do we mean by sedimentology? We are basically talking about how organic matter, which are the foundation for the formation of crude oil and natural gas, how they are laid in beds in the ocean floor. Is it clear? How they are laid in beds in sediments, layer by layer, on yearly basis. That is the basis of sedimentology. And I've told you that when these materials are laid in layers in that format, that there is what is called overburden pressure. That is the ones on top, they exert a pressure on those that are down below it. Is it clear? That pressure itself is one of the bases of the formation of crude oil and natural gas. Because for crude oil and natural gas to form, then temperature must be very high and pressure must be very high, bacterial action and other things. So shale, that is S-H-A-L. Shale is a source rock. Please take note. I've told you what is source rock. The rock from which the crude oil was formed. Source rock, shale is both a source rock and the reservoir rock. I believe you are hearing me. A source rock is the rock from which crude oil is formed. Is it clear? Now, shale is both a source rock and a reservoir rock. Is it clear to you? Some people used to argue that shale is not a reservoir rock. Somebody has argued with me before in class, in a master's class, that reservoir rocks are only dolomite, limestone, etc. But shale, as you see it here now, is both a source rock and a reservoir. What does it mean? I told you that after crude oil is formed, that the crude oil migrates to reservoirs. You remember I told you that last week Tuesday. I said after crude oil has been formed from the source rock, they migrate within the source rock as primary migration, and they migrate to reservoirs as secondary migration. Don't forget, I told you that last week. And I've also told you that migration of crude oil and natural gas can continue forever if they don't find a reservoir that is also called a trap. And I also told you the different types of traps. That is by the wayside. So, but this is a technical aspect of this code that you need to understand. You need to reason it and understand it. Now, shale as a source rock, where the crude oil is formed there, or natural gas, it doesn't migrate to traps. Is it clear to you? It doesn't migrate to reservoirs because shale itself is a reservoir on its own. So that is that. Please understand it. Now, petrophysical properties of potential reservoirs. Please listen. Petrophysical properties of potential reservoirs. You know what a reservoir is? A reservoir is a body of porous and permeable rocks. I've explained what is porosity. I've explained what is permeability. There's no geologist that is taking this course that does not know the meaning of porosity and permeability. If you don't know before, I explained that last week. I told you that porosity is the ratio of pore space in a rock over the bulk volume expressed as a percentage. So different reservoir rocks have different porosities. That is the implication. So the porosity of shale the porosity of dolomite, the porosity of limestone are all different. They don't have the same porosity. That is that porosity. I went ahead to explain the meaning of permeability for those that were not around. Permeability is the ease with which oil, crude oil, and natural gas move within the pores of a reservoir. Is it clear? The reservoirs are linked together, and the ease with which the crude oil move from one port to the next is what is called permeability. Permeability is a very important factor in crude oil and natural gas production. So, of any potential reservoir rock is that it must be permeable. And the permeability of determined by the state of the sediment. Is it clear to you? Maybe I'm too fast. I will come at the permeability, because what makes a rock is that it must be permeable, be porous. Is it clear to you? Otherwise, that cannot be called.
Engineer Joshua, please, you'll be muted. Unmute yourself. You'll be muted. Engineer Joshua, please unmute yourself. You'll be muted. Unmute yourself,
I don't know why
please.
this mute somebody. Will now be okay. Yeah, I don't know where I stopped before I was muted. So, but I'm trying to explain to you that porosity and permeability of a reservoir rock, which you know the meaning of a reservoir rock, are determined by the texture of the grains. You know what is called grains? That is the particles that make up the rock. Those are the grains. And the structure of the sediments. Is it clear to you? The structure now means the arrangement of the sediments. Grain size and grain arrangement are different. Is it clear to you? The grains can be arranged in a cubical form. They can be arranged in a hexagonal form. They can be arranged in different form. So whether the grains are arranged in a form of a hexagon, or in a cylindrical form, or in a cubical form, also affect the porosity and the permeability. Is it clear to that? What I mean by structure? And I was explaining to you the meaning of texture. That is whether the grain size are large or whether they are small. Is it clear to you? So that is that. Now, if the grain size are very tight, they call them tight sand. The porosity will be very, 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 very low. The permeability will be very, very low. So take note of those two factors. Now, sedimentary rocks that forms reservoir rocks are divided into clastic and carbonate. Take note of it. Write it down. It's very important. Sedimentary rocks are divided into two categories for the purpose of formation of reservoir rocks. You have the clastic and you have the carbonates. Clastic sedimentary rocks include siltstone and sandstone. Is it clear? And carbonate sedimentary rocks include dolomite and limestone. I'm going to come again. Sedimentary rocks are the foundation of petroleum reservoir formation. Is it clear? The reason is that they are porous and permeable. Now, I'm not telling you that the sedimentary rocks themselves are further divided into two types. We have the clastic and the carbonates. The clastics include silt stone, S-I-L-T, silt. Those of you that are close to those women that are sweeping the road, those sweepers in Lagos, when they sweep those small sand from the road, you see how fine those sand is. They even said them. Those are silt. Is it clear? So those are silt stone and sandstone, which make up the clastic. Then the carbonates are limestone and dolomite. These are the various types of reservoir rocks. Is it clear to you? Now, sedimentology, by definition, please write down. Sedimentology is the study of sedimentary rocks. I come again. Sedimentology is the study of sedimentary rocks. This study is concerned with their composition, structure, texture, and the origin of these properties. Is it clear to you? What property are we talking about? Composition, structure, and texture. How come about all those composition? How come about all those structure? How come about all those texture? I've explained the meaning of texture as size of grains. I've explained the meaning of structure as the arrangement of the grains, whether they are arranged in a hexagonal form, they are arranged in a cubical form, or they are arranged in a octagonal form, in any shape. That is their composition. What are the minerals that make up those rocks? That's what I mean by composition. Is it clear? So the origin of those properties. So depending on where the reservoir rock is found, the depositional environment will determine the chemical properties of the rock. Is it clear? So that is the depositional process that created sediments and the genetic processes that create the sedimentary rocks. Is it clear what we are talking about? What are the processes that form those sedimentary rocks? Is it clear to you? Were they formed due to glaciers, ice region? Were they formed due to heavy erosion, or the sorting process? Those are what we are talking about here. Now, I'm going to talk about sediment texture, which I'll be explaining to you since. I will just give you a summary of sediment texture. Texture is the general term used to describe the size, the shape, and arrangement of grains. Is it clear? Matrix and cement in the sedimentary rock. Now, when we are talking about cement, now the environment where sedimentary rocks are deposited at the ocean bottom, most times are clay soil environment. Now, when those sediments are deposited, clay is going to come in between them. They call it cementing. Maybe we are still going to talk about cementing in this course. Clay soil is going to come in between those particles, separating one grain from another. That is called cementing or cementation. Is it clear? So that's what we mean by grain matrix and cement in the sedimentary rock. It controls the reservoir properties like porosity and permeability. Is it clear? So grain texture is one of the basic determinants of the permeability and the porosity of a reservoir rock. Is it clear? That will now take us to what is called sorting. Sorting is very important in petroleum geology. Are you listening? So we're going to talk about sorting. Now, I'm going to explain sorting to you because the write-up here is very large. I will just explain to you and you will understand it. Now, when particles are broken down by a process of weathering, you know what is called weathering in geography? Weathering is the breaking down of particles of rock. Weathering is the breaking down of particles of rock by the agents of denudation. I come again. Weathering is the breaking down. Some textbook we say breaking up, self. You can use any. You say breaking down, breaking up, of a rock into smaller particles by the agents of weathering or agents of denudation. Example of agents of weathering include rainfall, include frost, that is ice, include animals, plants, biological weathering, chemical processes. They break the rock into particles to form soil. So when those particles are broken down, then there is breeze. You know what is called breeze or wind? Let me use wind instead of breeze. Wind will move all those particles. Then even erosion will move all those particles. We move them over different distances. Those particles that are broken down into smaller particles will be moved over short distance and they will settle there. Why those, they will move over large distance. They will travel over a large distance because the density and they are small. So they were able to move over a long distance. But those particles that are broken down into large sizes will not be able to they will not be able to transport over large distances. So particles that are of the same size will be in the same spot. That is what is called sorting in a nutshell. Particles that are of the same sizes are deposited in the same environment. That is sorting in a nutshell. So grain size and sorting depend on the physical conditions of the deposition environment where the grains were deposited and can be shown to have a relationship with the proximity to the sediment source. Is it clear? Or the distance transported and the nature of the sediment source. Is it clear to you? Is it igneous rock? Is it sedimentary rock or is it metamorphic rock that you are transporting? That will also determine the distance that they are going to travel. Then the energy of the environment of deposition. If they are deposited in the ocean floor, you know that there's going to be strong ocean currents and any fluctuation in the current over time will determine the sorting of those particles. Is it clear to you? So that is what we mean by sorting. Then I think with that, I'm going to take another subtopic. But before I take another subtopic, I will take my time to explain some the technology of or the engineering behind porosity and permeability in a sedimentary rock. Is it clear? Don't say we are talking about permeability and porosity too much. This the porosity and permeability is the basis of geology. Is the basis of petroleum engineering, transport, production of crude oil, even the exploration of crude oil. Porosity and permeability play an important role. And for the oil to move inside the rock, the reservoir rock, to the production wells and to the production wells, to a very large extent, depends on porosity and permeability. So I'm going to be talking about porosity and permeability based on the morphology of the reservoir rock. Is it clear to you? That is the sedimentology. How are they arranged? That's what I'm going to be talking about. Now, the porosity and permeability of the sedimentary rock depend on both the original texture of a sediment. Please, it's good you write this one down. The porosity and permeability of the sedimentary rock depends on both the original texture of a sediment and its diagenetic history. Is it clear to you? What I mean by original texture is that the source of the rock, is it from a sedimentary rock? That is the rock that later formed this, because organic matter must mix up with rocks to form a sedimentary rock. So the source of that rock that joined the organic matters to form a sedimentary rock, is it from metamorphic rock? Is it from igneous rock or a combination of both sedimentary, igneous and metamorphic rock? Is it clear? So that is that. Then the diagenetic processes are, the diagenetic history is the erosion, the processes that lead to the formation of the rock. So the original texture of a sediment controls the depositional porosity and permeability. I'm going to come again. The original, by now you know the meaning of texture, we are talking about the grain shape and size. So the original texture of a sediment controls the depositional porosity and permeability. That is the porosity and permeability immediately after to you. Sediment are deposited in about, mind you, an environment. Take note that differences of the grains at deposition are going to be different after. Is it clear? It's never constant to another. Is it clear to you? So, okay, yeah. So most sedimentary rocks, before I even go to this aspect, let me explain this other aspect to you. I explained this aspect to you for in the classroom. I said controls the depositional porosity immediately after the sediment with the ocean floor is going to be different from the permeability after many years. To you, for example, you paint your house this year now. If you paint your house this year, you see the beauty of the house. Come and check that house after 10 years, after 15 years. You will see the paint, how it has changed because of environmental factors. Is it clear? So happy because the rocks have been acted on, the sediments have been acted on now by ocean by ocean current and other factors. The permeability and the porosity of the rock of the sediment or the sedimentary, let me use sedimentary rocks, is going to change over time. So the porosity of a rock maybe 100 years ago is not going to be the porosity today because of action of ocean currents and other factors. So that's that. So we are saying that that the influence of final primary porosity and permeability are affected by geographical factors. Now, this is the aspect I want to really draw your attention to. In most sedimentary rocks, please take note, very important. In most sedimentary rocks, that is AISOP. In most sedimentary rocks, permeability is anisotropic. That is, it has different values in different direction. I don't know if you are following what I'm saying. What we mean is that the permeability is not constant all over the place. For example, if you have a sedimentary rocks that extend from Lagos State to Ogun State, or you have oil feeds are in different sizes. We're not going to talk about them in this course. When we are doing petroleum economics, we talk about those things. Now, oil feeds are vary in sizes. There are oil fields that can extend from here to Benin Republic, from Lagos State, from Lagos mainland, down to Badagry, down to Benin Republic. You can see the size of that sedimentary rock. That is a large oil field, what we call a world-class oil field. Now, if a sedimentary rock extends from Lagos State, from Lagos mainland, say from Yaba area, down to Badagry, down to Benin Republic, you see that it's the same sedimentary rock, but the porosity at various parts of that rock are going to be different. The porosity in a Lagos mainland may be different. It's going to be different from the porosity when you get to Yanoba site, when you get to Badagry, when you enter when you get to the border, Sebe border, when you now get to Benin Republic, the okay, it's muted now, Pastor Chris. Yes. So please, sorry for that small break in transmission. Somebody was calling, and again, the network, there was issue with network signal. So Generally, permeability is lower vertically than horizontally. Is it clear? So when you are going down the rock, permeability will be lower than when you are going vertically. That is when it is traveling straight. That is movement from north to south. Please take note of this, it's very important. In a reservoir rock, you know these rocks are underground. I believe you know. These rocks are thousands of feet underground. So when you are traveling north to south, that is vertical. Eh? Cardinal point, the permeability is going to be very low, is lower. But when you are traveling east to west, that is vertically, horizontally now, permeability is higher. And that is very good for the oil industry because okay. Yes, I am back. I'm sorry for the break in transmission. I was trying to explain to you that there are many factors that controls porosity and permeability of a reservoir rock. Is it clear to you? And one of them is grain size. I'm not going to explain grain size again. Yes, one of the factors is grain size. Is it clear to you? I've explained it before. I said that the grain size, eh? I'm hearing sound. Yes, okay. How does grain size affect porosity and permeability? Yes, now in practice, porosity tends to increase with decreasing grain size. Yes, put it. Yes, I don't know if people are still there. If you are still listening, please. What I'm trying to explain to you is that porosity tends to increase with decreasing grain size. Is it clear? Please write down porosity increases with decreasing grain size. Eh? For two reasons. For two reasons. Finer grains, especially clay, tend to have less regular shapes than coarser grains, and also are often less efficiently packed. Is it clear? So that is that. So, but in a nutshell, what I'm explaining in a nutshell is that porosity increases with decreasing grain size, while permeability decreases with decreasing grain size. Is it clear to you? So when the grain size are very minute, are very fine, eh, porosity will increase, but permeability will decrease. That is one of the factors that controls porosity and permeability. Now, another factor that controls it is called sorting. Another factor that affects porosity and permeability is called sorting. And I've explained the meaning of sorting before. I said sorting simply means how the grain size are arranged, how the particles, the sediments are arranged based on sizes. Is it clear? Then we also talk about grain shape. Grain shape also affects permeability and porosity. Now, grain shape simply means whether the okay, let me read this one to you. As permeability is a vector rather than a scalar quantity, grain shape will affect the anisotropy of the permeability. The more equal dimensional the grains, the more anisotropic the permeability tends to be. So the more the grain shape affect permeability, whether the shape of the reservoir, whether the grains are cubical, whether they are horizontal, whether they are hexagonal, those affect it. Then packing also affects porosity and permeability. You know what I mean by packing? You see stones. When you are wherever you are taking this class now, you are going to see stones in your area. You see that stones have different shapes. Is it clear to you? Those things are natural. Those things are natural. Is it clear to you? So the arrangement, the packing, the closer the packing, the lower the permeability and porosity. Is it clear to you? So what we mean by packing, the closeness of the grains to each other. For example, just take a stone, for example. A natural stone, take it for example. Put it inside water or try to pass water through it. Water cannot pass through it because the packing, they are very, very tightly packed.
That's the new one.
Yes. So as I was explaining, I said packing affects both the porosity and the permeability of a reservoir rock. The packing is PACKING. That is the way you pack things together. So if the packing is very, very tight, then the porosity and permeability is going to be very low. But if the packing is loosely packed, the porosity and permeability is going to be very high. Then that is that. Then another factor, which is the fifth factor that affect porosity and permeability, is the grain morphology and surface texture. Grain morphology and surface texture. Take note, this surface texture is different from grain size. Is it clear to you? And it's also different from grain shape. Now, the smoother the grain surfaces, the smoother the grain surfaces, the higher the permeability. Please take note of this point. Take note of this point. The smoother the grain surface, you know, smooth stone. If you go to the bottom of the ocean, you see very smooth stones that they are not they don't have contours. Is it clear to you? Very smooth stones, just like pebbles. It affects permeability of a rock. So if the particles are smooth, the permeability will be very high because the ease with which fluid will move pass through it will be easier. But if the surface were rough surfaces, then some of the fluid that are moving are going to be entering inside the interiors of the grains of the let me say of the sediments. So the movement will not be smooth. Is it clear to you? That is how grain morphology and surface texture affect permeability of a rock. So we are going to leave this aspect now and go to what another subtopic, go to what is called petroleum play. Go and write it down. It's part of exploration. Go to petroleum play. I'm going to rush it and quickly go and teach you seismic that we started that last week that we didn't finish. Because today is the last day for this course, I'm going to rush this aspect. When I rush this aspect, I will quickly go to seismic survey and still give you some points there. So we're going to be talking about petroleum play. Now, I'm going to define it for you, but let me explain some things in geology first of all. Now, the method by which explorationists, that is, explorationist is the same thing for geophysicists, geochemists, and geologists. That is the general terms for the three of them. Explorationists, these are the three people that are concerned majorly with exploration for mineral resources, crude oil and natural gas. Geologists, geophysicists, and geochemists. These three professions come together. In some cases, petroleum engineers also join because the petroleum geology is part of the course taking petroleum engineering. So when they come together, they evaluate the geological conditions. They evaluate the geological conditions of the environment through what is called the petroleum play. I'm going to explain this again. I am going to explain this point again to you. And what am I saying? I said the method by which explorationists, that is geologists, geophysicists, and geochemists, the process by which they evaluate the geological conditions of an environment where there is likelihood of crude oil deposits is referred to as petroleum play. Is it clear to you? Now, the petroleum play is a perception or a model of how a specific region of the earth subsurface may be an appropriate target for exploration drilling. Let me come again. The petroleum play is a perception. Please take note. Geology is not a precise science. I explained it before that you have done your exploration in an area and you have discovered petroleum rocks. It's not a yardstick for you to carry your drilling rig to that place and start drilling for crude oil and natural gas. Is it clear to you? There is need for evaluations and re-evaluations before you can say, yes, this environment is an oil or gas province. Is it clear to you? So that is why I use that word perception. Please take that. I'm explaining that word perception. So a petroleum play, the petroleum play is a perception or a model of how a specific region of the Earth's subsurface may be an appropriate target for exploration drilling. Now, exploration drilling is also called wildcat told you. Yes. Please, I'm sorry for that break in transmission. It was due to signal problem. I'm talking about petroleum play. I'm talking about the petroleum play. It's good that you people in geology, the people that do exploration, whatever is called a petroleum play. Is it clear? I have told you that geology or exploration is not a precise science. What I mean by that is that you are not 100% sure that the area where you have seen where you have discovered petroleum rocks or features that will give you the area where you have the features that are likely to hold crude oil. Even though you have discovered those features in that area, that is not a yardstick for you to say, yes, there's crude oil in this place. Yes, there's natural gas in this place. It's not a yardstick. I saw a stratigraphic trap. Yes. I saw a salt dome. Yes. Those are some of the features that I saw a migration route. Eh? I saw a migration route. Yes. That all those things are not a yardstick for you to say 100% that there's crude oil in a place, that there's natural gas in a place. So petroleum play help us to understand what to expect. Is it clear? So now the petroleum play is a perception. It's a perception or a model of how a specific region of the earth subsurface may be an appropriate target for exploration drilling. The connection shall fuck up. Or you meant I never experienced anything like this throughout today. For the try too. It is evening or say yeah. Yes, as I was saying, yeah, as I was saying, changes anything, changes anything, didn't change anything. Yes. Yes. Please, I'm very sorry for that break in transmission. I am having problem with signal, so I have to start all over again. So that is why we had that issue. So, but because we still have time, don't worry. I'm going to cover all my what I have for you today. So I'm explaining what is called a petroleum play. I have defined petroleum play. I'm now explaining for you to understand what it means. I said the petroleum play is a perception or model of how a specific region of the Earth's crust may be an appropriate target for exploration drilling. And I tried to explain to you the meaning of exploration drilling, that since geology is not a precise science, what I mean by precise science is that you are not sure, you are not 100% sure. It's not like chemistry or physics, where all the theories have been approved and they are found to be correct. So even though you see geologic structures that can likely hold oil, all the conditions that can likely to the formation of crude oil in a place, that is not enough for you to say there's crude oil in this place. That's what I mean by precise science or perception. So models need to be drawn out. Is it clear to you? So that's what I mean. Then I now explain the meaning of exploration drilling. I said exploration drilling is the same thing as wildcat drilling. What I mean by wildcat drilling, I mean that the drilling that is done to gather geological information, just to know the geology of that place, is not for the production of crude oil or natural gas. We just drill it to get more information, more understanding of that environment, oil bearing, that region, that province. Is it clear to you? So I proceed. Specifically, if it deals with how a producible reservoir, that is the rock that is connected to a connected pore or fracture system. What we mean by producible reservoir is that reservoir that is porous and permeable. Just leave it like that instead of talking stories. So a petroleum play, number one, deals with producible reservoirs. This with how a producible reservoir, that is a reservoir that is porous and permeable. Then number two, petroleum charge system, that is the source rock for the hydrocarbon and its migration path to the subject reservoir. And C or three, regional top seas. So specifically, I'm telling you that a petroleum play deals with oil and gas reservoirs. It's number two, deals with the source rock. Number three, it deals with the cap rock. A cap rock is a seal. We were talking about seal that last week. There are two types of seal. We have the top seal that prevent the crude oil or natural gas from migrating to the surface. Then we have side seals that prevent the crude oil from migrating horizontally forever. Is it clear to you? So petroleum play also deals with the cap rock. Is it clear? Then 4 or D, it also deals with the trap. The traps. That is the geological features defining the physical limit to the reservoir rock in the subsurface. That is the trap. In some cases, a reservoir is also referred to as a trap. Is it clear? So that will now lead us to the definition. Let me check that whether I will go straight to the other aspect. Let me quickly finish this one. Let me quickly rush this and go to seismic survey. Then, please, we are going to talk about a prospect. Please write down. A prospect is an identified trap. A prospect is an oil prospect or a gas prospect, or we call it petroleum prospect, is an identified trap. Either structural or stratigraphic, which has the following properties. This aspect is very important. So please write down. The subtopic is prospect. And I'm now telling you that a petroleum prospect is an identified trap, either stratigraphic or structural. I explained all those things in my last class. I explained what is a stratigraphic trap. I explained what is a structural trap in my last class. I also explained what is a combination trap. There are 3 different types of traps, but some books even add a 4th type of trap. But basically, in petroleum engineering, we have 3 types of traps: stratigraphic trap, structural trap, and combination trap, which is a combination of both structural and stratigraphic. The shape, let me not go into too much details because of our time. Now, this trap, the I've explained the meaning of a prospect. I said a prospect is an identified trap. And I've told you that there are different types of traps. We have structural trap, stratigraphic trap, and combination trap. And these are the following properties of a prospect. What makes a trap to be a prospect are the following. Number one, must have reasonable chance of containing rock that are porous and permeable. Number two, is older than the time when oil and gas was available. That is, oil and gas or gas migrate from a source rock on reaching thermal maturity, that is heat maturity. Then number three, is in a location in which oil and gas could be moved, could migrate. Then number four, is of sufficient potential size with enough confidence, that is probability that oil will be found to warrant drilling and exploration wells. That means it must be, the oil must be found in sufficient quantity to warrant our investment in drilling and production. Is it clear? Those are the four factors that make a prospect to be called a prospect. Is it clear? So I've explained what is a prospect, that a prospect is an identified trap that is either structural or stratigraphic, which must have reasonable chance of being porous and permeable, then must be in a location in which oil can migrate to it, must be economically viable, etc. So that leads us straight to geophysical exploration methods. Please write down geophysical exploration methods. That I explained, I started this last week. When you know the things I've taught you now and you understand geophysical exploration methods, then you have got a good foundation in exploration or petroleum geology. Is it clear? So geophysics, please write down geophysical exploration methods. That is a general topic. It's not a subtopic, it's a general topic. So write it down. Geophysical exploration methods. Yeah. I'm now defining geophysics. Geophysics is the subsurface site characterization. I come again. Take note before I go further that what we are studying in geology is not seen with the naked eyes. We are studying things that are thousands of feet below the earth's surface. Is it clear? So geophysics is the subsurface site characterization, that is modeling. Please, in the place of characterization, you can write modeling there if the English is too large. So let me come again by saying geophysics is the subsurface site modeling of the geological structure, groundwater contamination, and human artifacts beneath the earth's surface. I'm going to define it again. Take note, Geophysics is one basic aspect of exploration. Geophysics and geophysicists, geochemists, and geologists, these three professions are the main professions that come together to carry out exploration of crude oil and natural gas. So I'm dealing with the geophysics aspect of it now, because we are going to be talking about geophysical surveys. So now I said geophysics is the subsurface site modeling of the geology, geological structure, groundwater contamination, and human artifacts beneath the earth surface based on lateral and vertical mapping of the physical property variations that are remotely sensed using non-invasive technologies. This definition, you may look at it as too complex, but there's nothing complex here if what I'm telling you now is practicalized. Is it clear? What we are talking about is that we are using technology, non-invasive technology. What we are talking about, when I was talking about sending signals to the earth crust, what we are talking about sending signals through body of water and recording the signals that are sent remotely and analyzed by experts to give results to show whether the area is actually an oil-bearing environment or it's an environment that does not have oil. Is it clear to you? Or the environment does not have sufficient oil to warrant investment in the project. Is it clear? So that is that. So it's not a difficult definition, but I'll have to quickly move ahead because of our time. Geophysical survey methods. The task of explorationists are number one, yes. I said the task of explorationists. When I say explorationists, you know we are talking about geologists, we are talking about geophysicists, and we are talking about geochemists. Their tasks include the following. So if you are studying petroleum geology or you are doing exploration, as in this class, we are doing introduction to oil and gas exploration, then what is your task as an explorationist? Your number one task is to find source rock. You know the meaning of source rock by now as an explorationist. A source rock is the rock from which the organic matters from which crude oil were formed. Then they are looking for reservoir rock, they are looking for migration paths, they are looking for traps, and they are looking for sieves. You understand all this since I explained it last week. Now, when they have answered the following questions, the question the exploration are going to answer are: do we have a source rock? Do we have a reservoir rock? Do we have a migration route? Do we have traps? And do we have seeds? When these questions have been asked correctly, then they have to now dig deeper. That we are able to answer those questions does not mean that we are 100% correct, that crude oil is in that place. So we have to dig deeper and be 100% sure that we are not going to waste our investment when we start drilling for oil and gas in that province. So what are we going to do? More questions are going to be asked, are going to be answered. Number one, what is the thickness of the source rock? Is it clear to you? Please write down. Which type of hydrocarbons are in the source rock? What is the thickness of the reservoir rock? Mind you, source rock is different from reservoir rock. You know by now as an explorationist. Then, what is the speed points? Then, what are the closures? Those closures are the same thing as seas. Then, what is the depth? Where are we going to find this crude oil? Is it 10,000 feet? Is it 12,000 feet? Is it 20,000 feet? All these things must be known before we can start drilling for the oil or gas. Is it clear to you? So having answered those questions, when we have answered those questions correctly, we can now do what is called exploration drilling that I was telling you about. Is it clear to you? Now, the technique of answering the questions I gave you above is from seismic survey. Is it clear to you? Now, I'm going to briefly explain seismic survey from where I stopped last week, but this I'm going to go into more depth. I'm going to list them out quick because of our time. Now, in seismic survey or in seismic surveying, seismic waves are created by a control source. I come again. I told you that there are different methods of surveying for crude oil or natural gas. I told you that we have gravimetric method, we have magnetometric method, and we have surveying method. That is seismic surveying method. I also remember I told you that the seismic surveying method today is the most reliable method of exploration for oil and gas. Is it clear to you? So we are not going to touch, although in my class I taught the students the magnetometric method and the gravimetric method, but here I'm going to just talk about the seismic method. So that's what I'm talking about now. In seismic method or surveying method, seismic waves are created by control sources and propagated through the subsurface. What we mean is that you create a signal, a disturbance. You can hit a hammer on the ground. You can blast a dynamite through the earth. When you blow the dynamite, some waves will be sent to the earth crust. Is it clear to you? Now, when those waves are sent to the earth crust, they are going to be meeting different type of formations. They are going to meet metamorphic rock, igneous rock, sedimentary rocks, body of water, different types of formation with different type of chemical properties, different color, different texture, different grain size, different grain arrangements. That is what the signal is going to meet. Is it clear to you? So when the signals are sent to the earth crust, those signals are going to come back. You would have done waves in physics, sound waves. You would have done it in physics. That is what we are practicalizing here now. So when those waves are sent to the earth crust, because they are going to be meeting different materials of different densities, they are going to send refracted and reflected rays or waves. Let me use rays back to the surface. Is it clear to you? So some waves will return to the surface after refraction and reflection at geological boundaries within the subsurface. Is it clear to you? Then number 2 point, instruments are distributed along the surface to detect the ground motion caused by these returning waves and hence measure the arrival time of the waves at different ranges from the sources. Those instruments are going to be recording the waves that are sent back, the refraction and the reflected rays. Those instruments are referred to as geophones when you are doing your surveying, your seismic surveying on land, and hydrophones when you are doing your seismic survey in a body of water, maybe in an ocean environment. Is it clear to you? That is that. Then number 3, these travel times are converted into depth. How are they converted? You convert them by using the formula V equals 2x over T. I gave you this formula last week. You convert the waves because they are going to be traveling at a velocity. You convert to V equals 2x over T, where V is the velocity, x is the length, that is the distance, and T is the time. So you say Vt equals 2x. You now say x equals Vt over 2. Is it clear? So when you know the arrival time and you know the velocity of travel, you divide by 2. That will give you the depth. Is it clear to you? So with that, you know the distance where the petroleum is found or the natural gas is found. Is it clear? You have done that. Then the propagation velocities of seismic pulses are determined by the elastic moduli and densities of the material through which they pass. I've explained that. Then information on the compressional and shear waves velocities Compressional waves are represented by Vp, V subscript P, and shear waves are represented by V subscript S. Different rock materials have different compressional and shear waves. Is it clear? Different rocks and materials have different compressional and shear waves. And I told you that the symbol for compressional wave is V subscript P, and the symbol for shear waves is V subscript S. Is it clear? So they are going to encounter these different type of waves. Is it clear? In the seismic survey. So, and they are important in that they are used to convert into depth. Is it clear? They are used to convert into depth. They also provide, okay, let me explain it better by saying information on the compressional and shear waves velocities of
Engineer Joshua, please, you've been muted. Unmute yourself.
I've succeeded in explaining to you how seismic survey method, which is the latest method of exploration, is done. But before our time elapses, let me quickly give you your assignment for today. You are going to define the following terms for me. Number one, define petroleum play. Define the following terms connected to exploration. One, petroleum play. Two, prospects. Three,
Engineer, please time up. Please time up.
please, I believe you are listening seriously. I believe you are listening. Number three, primary migration. Secondary migration. Secondary migration of exploration. Number two, briefly explain the seismic survey method of exploration. Number one, I said define the following terms connected to exploration of oil and gas. Petroleum play. Two, prospect. Three, primary migration. Four, secondary migration. We are going to explain all those things. Then number two, I said explain in Yes. I'm sorry for the signal. The signal, the glow signal is really bad this evening. But I was trying to explain to you what is called seismic noise. Is it clear? Now, when you are doing your seismic, I've told you that you are going to send signals to the earth crust. Those signals are sent either with explosives.
Time up, engineer.
They are either with explosives. In the course of sending signals with explosives, you know that a lot of noise is going to be generated. Now, seismic noise, this is an unwarranted signals that contaminate the seismic data. Please write down seismic noise. This is all unwanted signals. This is all unwanted signals that contaminate this seismic data. Is it clear? But when you are doing your, when the geologists, when they are processing the data, unwanted data signals are always removed. Then the signals that have the correct information are what are processed. So what I'm telling you in essence is that not all the signals that come back to the surface is not all of them that are used. Some signals that are not wanted are discarded as useless, while the real data are used. Now, the types of seismic noise, number one, you have ambient or background noise, e.g. wind,
Time up. Please time up.
etc. Then number two, source generated noise, noise from the engine that you are using to send your signals. Then we have